So, a very good morning dear students, welcome to my channel Maths with Mahanti sir. Children, in the last class we discussed how to construct histogram of a continuous group frequency distribution when the width or size of each class is same. I mean, if you are given a continuous group frequency distribution with uniform width or size, how to construct the histogram? It was discussed in detail by me yesterday. Okay. So, today let us see. Suppose you are given a continuous group frequency distribution, but the width is not same. How to construct the histogram? So, what I mean to say, see, suppose you are given a frequency distribution. Look at. Suppose you are given look at the class intervals. Class intervals are 10 to 15, 15 to 20, 20 to 25. See, in each case, upper limit and lower limit. Here, upper limit 15, lower limit of the next class is 15. So, they coincide. Upper limit of second class 20, lower limit of third class 20. So, they also coincide. Upper limit of third class interval 25, lower limit of fourth class interval is 25. That means, in all the classes or class intervals, we find that the upper limit and lower limit, upper limit of one class coincides with the lower limit of the next class or the succeeding class. That means it is a continuous group frequency distribution. Okay. But what about the width you see? Width or size? The width of first class, you find out upper limit minus lower limit, 15 minus 10, it is 5. Width of the second class, you see 20 minus 15, it is again 5. 20 to 25. Again the width of this class, third class interval is 5. In the fourth, 25 to 30. It is also the class size or width is 5, but you see here, look at the fifth class interval, it is 30 to 40, upper limit 40, lower limit 30. So, the size or width of this class interval will be 10, here 40 to 60, class size or width will be 20, 60 to 80 in the class interval, the size or width of class is 20. That means, even though all classes are continuous, they have not uniform width or uniform size. Their size or width vary. Okay. Now, if such a situation arises, that means if you found that classes are continuous but width is not same, width or size of class is not same, then how to construct the histogram? That we will discuss today. We are now going to discuss how to construct histogram of a continuous frequency distribution. Means all classes are continuous. That means in all the class intervals, upper limit of one class coincide with the lower limit of the other or the next or the succeeding class. But the width is not same. Like in the first 4 classes, the width or size is 5. But in the 5th class, the width or size is 10. And in the last 2 classes, the width or size is 20. That means width is not same or uniform. Then how to construct the histogram? What is the process? See children, in this case, when classes are continuous but width or size is not same. So what we will do? Now we have to adjust. You see, these are the frequencies. Frequency of first class 7, frequency of second class 9 it is given. We have to adjust the frequency. We have to adjust the frequency if classes are continuous but width is not same. Now how to adjust? Now the point is, so what will happen if we adjust the frequency? If we adjust the frequency, whatever adjusted frequencies of each class intervals will be obtained. Whatever adjusted frequency, after the frequencies, you see here frequency 7, 9, 8 etc. So we have to adjust their frequency. We have to adjust the frequency of each class. So what will happen if the frequency of each class is adjusted? If we adjust the frequency of each class, so whatever adjusted frequencies will be obtained, that will be equal to the corresponding what? Height of the bars or rectangles in the histogram. Okay. As I told you in the previous class, that in histogram we draw bars or rectangles in which the length will be proportional to the length of the bar or rectangle will be proportional to the corresponding frequencies, and the width or base, it is equal to the class limit. It is equal to the class limit or size of the class, whatever you say. Okay. But in case when the classes are continuous but width is not same, we have to adjust the frequency of each class. and by adjusting the frequency of each class, what will happen? Whatever adjusted frequencies are obtained, those adjusted frequencies of the class or class intervals will be equal to, or you can say proportional to, the corresponding what? Heights of the bars or the rectangles. Okay, now the point is how to adjust the frequency. How will we adjust the frequency, or how to find the adjusted frequency of a class? I mean all the classes or class intervals or group data when classes are continuous but width is not same. What is the formula? Let us see. In order to adjust the frequency, you see, in order to adjust the frequency means you have to find adjusted frequency of a class. You see, how to adjust the frequency of each class? Children, once again I am saying, when we need to adjust the frequency of class or class intervals, if the classes are, suppose in a given, you are given a continuous frequency distribution, but you found that all classes are continuous but width is not same. In some classes, suppose the width is 5, like I have taken the example. In some classes you saw that the width or size of class interval is 5, but in some other classes it is 10, 20, whatever it may be. So if the width or size of classes is not same, then you have to adjust the frequency of each class or class interval present in the continuous group frequency distribution to find the adjusted frequency of each class, because those adjusted frequencies of the classes or class intervals will be proportional or equal to the heights of the what? Bars or rectangles in the histogram. Now the point is how to find the adjusted frequency, or how to adjust the frequency of a class or class interval. The formula, you see, I am going to tell you the formula. The formula is minimum class size divided by minimum. What is minimum class size? I will tell you. Minimum class size divided by size of class into frequency. Frequency means frequency of the class. You see, if you remember this formula, you can easily find the adjusted frequency of each class or class interval. Okay. So, how to find the adjusted frequency of each class or each class interval, or how to adjust frequency? See, now in this particular case, we saw that all classes are continuous but their width is not same. So it is needed, or it is necessary to adjust the frequency. Now in order to adjust the frequency, you have to remember this formula: minimum class size by size of class into frequency of the corresponding class or that particular class. See, what is the minimum class size? See here the class size is 5, 5, 5, but in the first 4 classes, the class size or width is 5. In the next class it is 10, because it is given 30 to 40. See, 30 to 40, class size 10. Here the class size is 20. So which is the minimum class size? Definitely the minimum class size in this particular case is 5. Okay, so you have to find now adjusted frequency. See, adjusted frequency. Now how to get adjusted frequency? Using that formula. So minimum class size. What is the minimum class size in this distribution? In this continuous group frequency distribution, the minimum class size is 5, because here it is 10 and in the last 2 classes it is 20. So out of 5, 10 and 20, the minimum is 5. So the minimum class size is 5 divided by size of class. What is the size of this class? You see, 15 minus 10, it is 5 into, what is the frequency? 7. See. So minimum class size 5, size of this class is 15 minus 10, that is 5, 5 by 5 into 7. So what will be the adjusted frequency of the first class interval? That is 10 to 15, it will be equal to 7. Now find the next adjusted frequency of the next class. Again minimum class size is 5, size of the class is 20 minus 15, it is 5 into 9. So it will be 9. Again here, look at the third. Minimum class size 5, class size will be 25 minus 20. 25 minus 20 is 5 into 8. See. So the adjusted frequency of the third class interval will be 8. Now fourth one, you see, the minimum class size is 5, then size of class 30 minus 25 is 5 into frequency is 5. See. So it will be 5. Now look at the fourth. Look at the fourth class interval. What is the minimum class size we have taken? Minimum class size for all classes is 5. Okay, in this particular case. So minimum class size 5. What is the class size? 40 minus 30. You see, 40 minus 30 is 10. It is the size of this particular class interval, that is 30 to 40, into what is the frequency? 12. So 5 by 10 into 12, it will be 6. You see. Then now this class interval 40 to 60, what is the minimum class size? 5. What is the class size? 60 minus 40 is 20. So 5 by 20 into 12. 5 by 20 into 12 will be 3. So the adjusted frequency will be 3. Here the minimum class size is 5. What is the size of this particular class? 80 minus 60, 20 into 8. So 5 by 24, 4 into 8 is your 2. See. Now I got the adjusted frequencies of each class or class interval or group data. And why did I find the adjusted frequency? Because all classes are not, even though all classes are continuous, their width or size is not same. So I have to find, or we have to find the adjusted frequencies. Now after finding the adjusted frequency, what we will do? Take these classes, you see, the class intervals or class limits, you can say. Take the class limits along x-axis and take the adjusted frequency. This is your adjusted frequency. See, take the class limits along x-axis. Class limits means your lower limit, upper limit. You see, on choosing, already we have discussed how to construct histogram of a continuous group frequency distribution having uniform width or size. The same procedure you will follow. Only the difference is you will not take frequency along y-axis. You have to take the adjusted frequency. Okay, that is the only difference. Why you will take the adjusted frequencies along y-axis? Because even though classes are continuous, their width or size is not same. So you will not take the frequency along y-axis. You have to take the adjusted frequencies. That means first you will find the adjusted frequencies of each class or class intervals, then take class limits along x-axis and adjusted frequencies along y-axis on choosing appropriate scale along both the axes. So represent the class limits along x-axis, then represent the adjusted frequencies along y-axis and draw bars or rectangles. You see, look at in this particular case, the scale, you see, in x-axis the scale starts from 10, you see, not from the origin. As the scale, you know children, when the scale does not start from the origin, you see, here one big division, let me write the scale here. What is the scale in this particular case? In this particular histogram, the scale, you see, that I have taken, scale in x-axis or along x-axis, see, one big division. Along x-axis, one big division equal to how much I have taken? 5. But look at, the scale starts from 10, 10, 15, 20, you see, 10, 15, 20, 25, 30, 35, 40, 40, like this, 45, 50, 55, these are all missing, see. So here the scale does not start from the origin, the scale starts from 10 along x-axis. While taking class limits along x-axis by choosing the scale along x-axis or in x-axis, one big division equal to 5, look at, the scale starts from 10, it does not start from the origin. So you have to give a kink here. You have to give a kink. Kink, you know, kink or bent. It was discussed in class 8. We give a kink or bent on a particular axis if the scale does not start from the origin. As in this case, the scale starts from 10, not from the origin. Because I have taken one big division equal to 5, but I have not shown 5 here, see. I took directly from 10. From here to here, from origin to this point, it is one big division. I have written 10 directly, I have not written 5. So had I written 5 here, then there is no need to give a kink. But as I have taken 10, that means my scale starts from 10, not from the origin. Hence I have to give a kink or bend along the x-axis or on the x-axis. But look at the y-axis. In y-axis, you can say, in y-axis, one big division equal to how much? You see, this is origin, see origin, then 2, 4, 6, 8, 10, it has continued. That means along x-axis, one big division has been taken 2. One big division equal to 2. And look at, along y-axis the scale starts from origin, because from here to here it is one big division, from origin to here it is one big division taken 2, then from 2 to 4 it is another one big division, it is taken 4, that means 2 each. So one big division has been taken 2 along y-axis, and in this case the scale starts from the origin. So there is no need to give a kink or bend along y-axis. So only the kink will be given. Kink. See what is meant by kink? This is the kink. Kink or bent will be given on a particular axis if the scale does not start from the origin. So as in this case the scale starts from 10, not from the origin. So you have to give a kink along x-axis. But in y-axis there is no need to give a kink because one big division has been taken too along y-axis and the scale starts from the origin. Rightly or clearly. So okay, then you draw bars or rectangles. See, then you draw bars or rectangles. So I would like to summarize the thing, children. See, in case the classes are continuous but width is not same, what you will do? First you find the adjusted frequency, means you adjust the frequency of each class. By the formula, what is the formula I said? Minimum class size divided by size of that particular class into frequency of that particular class or class interval. You will get the adjusted frequency of each class. So after finding the adjusted frequencies of each classes or class intervals, what you will do? Take class intervals or class limits along x-axis, choosing suitable scale, appropriate scale. Then take the adjusted frequencies along y-axis on choosing appropriate scale. Okay. Then after taking class intervals or class limits along x-axis and adjusted frequencies along y-axis, draw bars or rectangles such that you will find that the adjusted frequencies will be proportional to the heights. The heights of the bars or rectangles, the heights, these are the heights, you see these are the heights. The heights or bars of the rectangles will be proportional to the corresponding adjusted frequencies, and what about the base? It is equal to the class limits. Okay, it is equal to the class limits or size or width of the class, whatever you say. So this will be the required histogram of the continuous group frequency distribution having unequal size or non-uniform, you can say non-uniform width or size. Okay, this is the process. Now the point is, we discussed two cases. In the last class we discussed how to construct histogram of continuous frequency distribution when having uniform width or size. In this particular class we discussed how to construct histogram of a continuous frequency distribution having varying or different width or class size. Okay, now the point is, suppose you are given a frequency distribution which is not continuous. Already I have discussed discontinuous or inclusive type frequency distribution. See, suppose you are given an inclusive type frequency distribution, okay, where the inclusive means discontinuous, classes are not continuous, means upper limit lower limit does not coincide, okay, but they have the same width. I hope you understood. Suppose you are given a frequency distribution inclusive type, means discontinuous, where you will find that the upper limit of one class does not coincide with the lower limit of the next class. Classes are not continuous, discontinuous means inclusive. Okay, you are suppose given an inclusive type frequency distribution, but the width of all the classes is same. Then what to do? How to construct the histogram? See children, in this case, if you are given, already I have told you, in all the cases the classes must be continuous. Okay, in order to draw histogram or in order to represent data graphically, whether by means of histogram or your frequency polygon that we are going to discuss later, the frequency distribution must be a continuous one. Okay, it must be a continuous one with uniform width. Okay, if it is not continuous, then it is not possible to draw the construct the histogram. Okay, so if you are given an inclusive type frequency distribution with uniform width or class size, in that case what you will do? First you change the inclusive type to exclusive type, means first you make the frequency distribution continuous as it is, as the given frequency distribution, suppose you are given discontinuous or inclusive type, make it exclusive or continuous. Okay, after it is converted into exclusive type or your continuous frequency distribution, then only you can draw, construct the histogram. Okay, so children, I discussed three cases. Case 1, when classes are continuous. See, once again I am summarizing the thing. Case 1, when classes are continuous having uniform width, how to construct the histogram. In this class I discussed when classes are continuous but not having uniform width, how to construct the histogram by finding what? Adjusted frequency, or by adjusting the frequencies of each class and class interval. And the third case, when classes are not continuous. If classes are not continuous but they have the same width, first you make them continuous. How it is done? How to convert inclusive type to exclusive type frequency distribution, already I have discussed and I am sure you must have understood. So if classes are not continuous, make them continuous and then construct the histogram. Okay. So with this we discussed almost all the cases of what? 3 different cases how to construct histogram. But still another case is left. Suppose you are not given class interval, you are given the midpoint of classes. Okay. How to construct the histogram? We shall discuss it in the next class. Okay. Children, I hope whatever 3 different cases I discussed, how to construct histogram of a frequency distribution, particularly continuous frequency distribution having uniform width and continuous frequency distribution not having uniform width. Okay, I hope whatever I discussed you must have understood. If at all it is true, please hit the like button and subscribe my channel. Okay, I shall discuss another important case when midpoints of classes are given, how to construct the histogram in the next class. Thank you.